We'll do a couple of these more challenging ones. So here we have g of x is negative 3x squared minus 1, and we have to find each value. And when they say find each value, well, for number 1, we would rewrite g of x equals, close that parentheses, I made a rushing mistake there, 3x squared minus 1. And when it says find each value, well, they're telling us to find the value of g when x is negative 4. So I'll make this green so that it stands out as what my input is. So yeah, you began with f of x, and then they kind of just increase to g of x and then h of x if you ever need three functions that are not specific. But like if you ever had like the probability of something, like the chance of something happening, you might be dealing with p of x. So there are times where definitely this letter has meaning. Or a of x, which would be acceleration, and usually the input is time, so you'd be like a of t. So there's all different reasons to use these functions, and it helps you with overlap, and it also helps you with real-world problems. So I'll slide this up because I got negative 3 times, but since I have an exponent attached to my value of x, I'd really like to encourage you to write the value of negative 4 in parentheses. So to make it kind of stand clear out, there's where I'm at. There's the x, there's the negative 4 directly below it. So that when I attach my exponent of 2 on x, I'm attaching it to the parentheses. And even though it shouldn't really matter for this one, it's going to help me to avoid making mistakes where negatives get multiplied and all that kind of business. Now we just got a PEMDAS problem, and there's a little bit more steps involved than in the ones before. Can't do anything with negative 3 yet, but 4 times 4 gives me 16, and a negative times a negative cancels out, leaving me with a positive, and from that I'm going to subtract 1. 3 times 16 gives me 48. Sneak that negative out there, and here's minus 1 to give me negative 49. And you can't check these in the calculator, because it's not like you're solving something. You had to evaluate something. You're evaluating an expression. Yeah, there are equal signs, but we're not solving. So you could turn to a neighbor and say, hey, did you get the same thing that I got? Or you could actually type this all into Wolfram Alpha, believe it or not. So you type in maybe this, assuming you were good, or you could type this in and then see what happens if you separate it with a comma or a semicolon before typing in g of negative 4 in parentheses. It's a lot of work, but it lets you know you're good moving forward. Now because in number 2, we're doing something super similar, 10 minus g of 1, I'm going to end up maybe reusing some of this. Actually, I'm not. Never mind. I changed my mind. So for problem 2, we're going to rewrite 10 minus g of 1. But what we remember is, we still need our function from earlier. So I'm going to skip a line, and I'm going to write g of x equals negative 3x squared minus 1, because I'm just writing down what g of x is. And now I think it's going to be nice if you end up using the left side and then kind of doing some of the work on the right. So you might need to get like an extra sheet of paper if you run out of room on these. So on the left side, I'm going to say, well, g of 1, because I need to figure out what that is before I can figure out what 10 minus that is. So I'm going to write g of 1 equals negative 3 times 1 squared. And here I don't need to use parentheses if I don't want, because it's not going to trip me up. Minus 1. Now maybe you know that 1 squared is 1 times negative 3 is negative 3, but go ahead and just please write 1 for now so that we see that the exponent became 1. So I got negative 3 minus 1, and that's going to give me negative 4. Now if I box it, no big deal, but we have to be thorough on these and realize that we're not done yet. And the reason we're not done is because we still have 10 minus g of 1, which means that over here when I evaluate 10 minus g of 1, I have to remember that I'm doing 10 minus, well, g of 1 is negative 4, So to help me with that negative, I'm going to open up a parentheses, and I'm going to write -4, which is going to help me not mess up changing that to positive and then getting 14 for my whole result. Your teacher's eyes would likely look to the right as for the final answer and not here, so this would stand out to me as the final result. So yeah, these are multi-step. Don't let that throw you off too much. Same deal here. You might be wanting to do this on extra paper. That's okay. And so as we start to close up on this final problem of these three, here's g of 0 plus 8, and I'm hugging the left side. I'm rewriting the original problem. Now to do that in steps, I'm going to write g of x equals -3x squared minus 1. So that when I plug in g of 0, because that's what we're told to figure out, I can clearly see that I got -3 times 0. Even though it's silly, we know that anything times 0 goes away. We're going to put that exponent there. But what I am okay with you doing is g of 0 can become nothing, because that's going to drop out, minus 1. So g of 0 is just -1. And then when I go in and I plug everything in on the right side, I'm going to want to stage my work. So here's g of 0 plus 8, which is what the original problem over here asked us to do. We're going to say, well, this is -1 plus 8 gives us a positive 7. And we're good. Like I said, can't really compare that with an original problem because we're not solving equations or anything, so maybe you turn to a neighbor and see if they got the same things as you, the back of the book, or use Wolfram Alpha. We're not going to have enough time to complete this whole video, so we'll hang tight before we jump into the real-world problems.